I first wanted to thank Dale for this great workshop. It's been very enlightening for me, so hopefully for everybody else. Today, well, in the last few days, we've heard seen and heard some really interesting examples of the types of interactions that I think he's talking about. We've seen examples of animal-animal interactions that Ari talked about, clearly animal and environment interactions, and animal and human interactions, and human-human interactions, and all these interactions take place in some space and some time. And an interesting question for me is, how do we start to think about how we might analyze these interactions? And what I would suggest and what I'd like to maybe point to in this presentation is what we might start to think about these interactions as sequences of events. So let me talk a little bit about some of the work that I've been working on. And this is funded by the National Science Foundation, for which I thank them very much. So the particular problem of interest that I want to talk about here is sensor networks. They generate, as we know, a lot of data, and it's very high dimensional data. We've heard examples of sensor boards on sensors that are collecting humidity, temperature, pressure, acceleration in 3 dimensions, just to name a few. And in addition to the variables that we're measuring, we also have the sensors normally at a location, or we want to track the location, or so we're georeferencing the position of these measurements. And then clearly we have a timestamp for all these measurements. And so we have this, again, this spatial temporal, rich spatial temporal and multivariate data set generated by them. It's also a very heterogeneous set. In other words, we have audio, we have video, we have time series. They're different formats. They may be, again, in very different spatial and temporal sampling resolutions. So again, a lot of heterogeneity in the types of data, as well as very high dimensional. So the particular case study that we've been targeting for this is an existing data set. The case study is this Gulf of Maine Ocean Observing System. It's been in place for over 8 years now, so there's 8 years of data. The spatial component is probably the most sparse. There's been 12, but there's on the order of about 10 moored buoy locations in the Gulf of Maine, which you see on the map. And at each of these buoys, there's several sensor packages. There's several at the surface measuring meteorological variables. There's multiple sensor packages at multiple depths, from the surface down to some of the deepest ones at 200 feet. And they're sampling anywhere from hourly to 15 minutes. As I said, now we have up to 8 years of total data, so it's a lot of data. In addition to the moored buoy programs, part of GOMUS is also monitoring some satellite data, sea surface temperature and winds. And there's also CODAR, which is getting a radar picture of sea surface currents. So a lot of data, again, different formats, and space and time is very important here. So the project goal has been, how can we integrate this diverse, heterogeneous data and be able to start to explore it and make sense of it in its space, time, and thematic context. And so the approach that we're taking is to abstract this sensor data to events. Now, you heard Peggy talk about events. And when I talk about events, it's a little bit different context than Peggy was referring to. But I'll say a little bit what I mean by events. So we abstract the sensor data to events. And we were developing an ontology for events, a semantics, a language for how do we talk about events, how do we query and ask for events. And then we want to develop a set of tools for how do we visualize and explore and start to analyze events in terms of primarily in terms of their spatial and temporal patterns. So what is an event in our context? Well, people said an event is something that happens in some place in time. That's very simple. I'd also like to say that it could be anything you want it to be. And it can be very domain specific. And I'll give you some examples, but those are very free-form definitions. And ultimately, we do have to be formal and specific about what is an event if we want to be able to replicate the extraction and detection of these events. So what we're saying in a more formal way is that an event is a unit of change, or it's a sequence of changes that we observe from the variables of our sensor network. And we can identify as some statistically similar pattern, and then we can apply a label to it as a discrete unit. But within that, there's a lot of possibilities. But fundamentally, what we end up with is events are something that we can assign a spatial footprint to, a spatial location, whether that be a point, a polygon, a polyline as a representation, and it has a temporal duration or a temporal footprint, and one or more descriptive labels, properties that we can attach to this event. So sensor data we can think of as taking a number of different forms, at least 3. There may be some more. We talk about, we can think of them as spatial temporal or spatial field of time series, a time series of spatial field, or moving point time series. And let me just jump to examples of these. So these sensor networks, again, we have nodes, and each node has a location, and in each node, we're, in a sense, collecting a time series. So what we end up with is a field of time series. What we're looking at here is the salinity data time series from 5 different buoy locations. Now, examples of events that might be of interest, if you're an oceanographer and looking, and this is salinity, we're looking at several years of salinity data. It might be these, do we have a pointer? It might be these spikes, these sudden drops in, is this it? Okay. So the events of interest could be a number of different things. It could be these sudden drops in salinity. That could be intrusion of some fresh water, any number of things. It could be this seasonal increase in the salinity. And that, so you see there's some pattern to it. It looks somewhat similar every year, but slightly different. So maybe that's the event of interest. Maybe it's the maximum each year. Maybe if we fit a model to this, it's the anomalies or the differences from that model. And actually, it turns out there was a major salinity anomaly. If you look at this one, it's a lot lower than it was in previous years. So anyway, there's a number of possibilities for what we call events in this data set. So another way, type of sensor data is the imagery, satellite imagery being a good one. So we get sequences of, in this case, sea surface temperature for the Gulf of Maine. And in this case, the events of interest could be another thing. There's sort of these blobs of potentially warm water or these cold water intrusions into the Gulf. And we might be interested in, again, their location and their persistence over time. So these actually have, again, shape. But we can reduce them to a spatial footprint and a temporal footprint. Another type of sensor data that we're acquiring a lot of is what we call moving point data. So examples of this would be animal tracking, could be, again, human tracking, anybody carrying a cell phone or a GPS receiver. And so here we have Stephanie the gray seal, and we see her tracks. And the events of interest could be, well, for track data, there's a number of possibilities. It could be the straight segments. It could be where they change direction. It could be where you have a change in acceleration. And it made me think of Ari's data, if you recall from the whales and the tracks that he had. You could very easily decompose that into things like the dive data, where you had the tail slaps, where you had the large circles, where you had the small circles, where you had the vocalizations. Those could all be interesting events. And so it depends on how you want to parse your data and what it is that's interesting to you in terms of your particular domain. So what we want to do is now we have, so let's say we come up with our events, parse our sensor data, so we have a set of events. What can we now do with them? And we have maps. We can plot our events in terms of maps and see our spatial pattern in terms of events. We can plot events on a timeline and see temporal patterns in our events. But what I wanted to get at is there a way to look at the spatial and the temporal structure in a more integrated way? And so we're working on what we call this event viewer, and it's specifically designed to explore and visualize events of the types I've been describing. So it assumes they have a footprint, spatially and temporally, and multiple event labels. So what we do is, this is really highly abstract. We're simplifying the spatial dimension and the temporal dimension to categories. So a map, if you think about a map is a metric space, and a timeline is also a metric space. So these are sort of a nominal category space. And the exploratory capability comes from, we have a set of graphic objects, and we assign our spatial, temporal, and thematic categories associated with events to these different graphic components. So the first graphic component, you can think of these as containers of events. So events occur in space, and events occur in time, or they have types. So the event band is our sort of bottom layer graphic component for displaying events. So you can think of it as a container again. And the events are expressed within this container. And there is a timeline associated. So we kind of think of time as a dominant dimension here in terms of, because we're looking at a dynamic phenomena and interactions. So the timeline is important. So that piece is not abstracted. But we have events in here that are displayed by their duration. And we can color code them by their type if we want to. Another important part of, again, dealing with sensor data is that often we can lose our signal. So we have time periods where there is no data. And if we're looking for event patterns in time, it becomes important to be able to distinguish where are there time periods where I have no events, or there are time periods where it's just that I lost my signal and I have no data. And so part of the visualization is to know where you have those two different cases. So we collect, in all cases, missing data events, and they are displayed as part of this. So in these bands, anything could be attached to those bands. So we can say the band is associated with a location, and the band could be associated with a time. In this case, let's say our example is that we want to look at low pressure events for 1 year and for 2 locations. So in this case, we're stacking up two bands, and the bands here represent location, in this case the location of the sensor or the moored buoy, and for a year. And this allows us to compare, well, what happened in 2005, and how did what buoy B saw in terms of pressure events compare with what buoy E saw in terms of pressure events. So these are going to have to be small. These are small multiples in Tufte's words. So you have to have these common graphic structure so that you can do these visual comparisons. So here's another example, again, so we can change the dimension of the category that we assign to the bands and the stacks. So in this example, we're representing time on the bands and location on the stack, and the stack is just a stack of bands, which I didn't say. So this allows comparison. So I look at buoy B, and how did buoy B's, what buoy B saw in terms of pressure events change between 2005 and 2006. Okay? So again, I'm looking at location and time in somewhat of an integrated way, hopefully. That makes sense. Now I can also, so I said I can put time on the bands, I can put space on the bands. I can also put event types on the bands. So in this case, we're assigning a theme to the band. And what this allows us to do is compare two event types and look for event-event relationships. So when I see pressure, is there any relationship between pressure and an increase in wind speed? And if I have an increase, a pressure drop event, is it always associated with, or does a wind speed event occur after that or before that? And I can start to look for patterns, and there's sort of a hypothesis formulation. Do I see patterns, and can I then start to test and see if they might be significant? And then there's a third, so we can start to add to this, so we can have stacks, and then we can have panels, and then we start to build up the complexity of this idea. So we can assign, now we have, in this case, theme assigned to bands, location assigned to, time assigned to stacks, and location assigned to panels. And again, so you start to add this, so you get sort of a, build up a picture of over space and time and themes. What are things that are happening, and how can I start to compare what they're happening? So in this case, I can look at what happens between 3 different locations, 2 years, and 2 different types of events. So that's, again, sort of the static view. What would be really useful is, and what we have is built in as the interaction, is that I can swap these category assignments. So in this case, I have time assigned to the stacks in these locations, the A, B, A, C, E, just our shorthand for our buoy locations. So I have time assigned to stacks and location assigned to bands. And in the interaction in our interface, we can just click those 2 categories and do a swap. And that just transforms our view. And what's possible here is that you might see patterns that you didn't see in this view. You see them in this view. Or it's a different comparison. So again, we're looking at how does, in 1 year, how did the events look across locations. In this case, we're looking at a location, and how did it change over time. Now let me show you another example of why swapping can be a really useful thing. In an exploratory context, if you can do this really quickly, you can start to swap and look for patterns. So let's say we're, given the H1N1 concern, let's say our events of interest in this case might be excess absences at schools. And maybe this is being monitored. So this would be more absences than you would expect on a day. And let's say they're monitoring this by school district and by month. And so we're looking at school districts, 5 different school districts for 3 months. Now let's say I quickly swap that. What happened? I didn't see this before. Now, well, something happened there. There's all these districts at about the same time in the month of March had excess absences. So suddenly I get, wow, I got a signal that something was going on there, and that's something I would want to explore. So the swapping is a really important part of the interaction then. Another advantage of this is that we can assign multiple spatial locations to the stacks and bands. They don't have to be different dimensions. So I can put space or my location categories on my stacks and my bands and start to explore the spatial structure in a little bit finer granularity. So in my case, I might want to have, so let's say my event of interest here is high flow events. And first level, I want to look at high flow events within watersheds and within streams. And maybe I want to have a little bit finer look at that and say, well, was the rainfall or the high flow events evenly distributed across the watershed? Was there any variation? So if I want to look at that, I can go down to the finest granularity, if it might have on my station flow gauges. And I can start to look at that and say, oh, well, at station 1, there were no high flow events. And maybe I know that's higher in the watershed, and I might expect that. But I can start to, again, explore things in different levels of spatial granularity with this structure. If I have in mind, again, some spatial categories of interest. And so far I've referred to assigning just discrete categories, sort of place names, place labels to the bands. But another possibility is to use bin values of some continuous variable, like latitude, like longitude, like elevation, azimuth. And so we can do bins, in this case latitude. And what this would allow us to do is to actually see if I have spatial trends. So in this case, am I seeing more events at lower latitudes than at higher latitudes? You might argue, but it allows you to explore the question of, do I have spatial spatial trends in my events? And I can do similar sorts of things with time. I can put multiple time categories on my bands and stacks and start to explore, again, different granularities in the temporal structure. So we might look at cold spikes, and this would be a really rapid temperature fall. And we might look at them across years and through months. And so I can say, okay, how did January fare over a number of years? How did it look in March, February? How did it look in March? And I might want to then explore it in more temporal granularity. So I can now assign, say, weeks to the stacks and months to the band. And there is a temporal interaction here, in that this timeline is constrained by our smallest temporal unit. Another interesting thing about the temporal structure is that if I have a repeat pattern, and it may be a repeat pattern that I know, but it also could be that if you just put it on a timeline, you might just say, ooh, is that repeating? But what you want to know is that repeating? How regularly is it repeating? And so what I can do is, in this case, we have an ice out as the event of interest. And I want us to look at ice out events over a sequence of years and say, how regularly do ice out events occur? Does it change over time? Is it getting earlier? Is it getting later with years? And I can see on average what it is for a particular lake. So I'm looking at one lake here. And now I can stack these up and create a stack for every lake that I have and compare ice outs for different lakes. And so again, you start to build up these combinations in different ways that will allow you to explore a lot of different phenomena. And then we can also partition the sort of the thematic dimensions of the problem and look at, in this case, we're looking at air and water temperature drops and spikes. So this would be a really rapid decline or increase in temperature, and comparing these in air temperature with those in water temperature. And what I might want to do is separate them out so that I have, again, sort of a finer grained view of these events. And what I might see is that now I'm just looking at the spikes together and the drops together. So we can rearrange them in different ways to, again, just explore, might be. And what we might notice is that there seems to be no relationship between drops in air temperature and drops in the water. But maybe there's a little bit more correlation between temperature rises in air and water. And why would that be? That's not a definitive trend there. But anyway, it allows you to, again, have lots of different possibilities that within the same context, we can switch around these dimensions and realign them and swap them. And so now we're looking at a lot of physical parameters. But I think in terms of the interaction question, now we could put the seals in here. So what's a seal doing when certain physical things are changing? What are human activities that might be going on in these contexts? So we can start to build up these contexts of physical events and what might be socioeconomic, maybe even legislative events that you might want to place in these. So the events, if you can think about it as a very general concept, and you can say they all have space, time, and thematic properties, and now we have sort of a common framework in which we can start to explore them. So in summary, the key idea here is that we have these events, this notion of events, that you can define however your domain interests might fall. And they're the central unit of analysis. And what we want to do is, or the advantage here is that with very heterogeneous data streams, we can create this, in a sense, a common unit of analysis that normalizes across that heterogeneity in our different data types coming from different sensors. So again, it gives us a format to look at these in one sort of common analysis setting. And this exploratory environment allows us to, again, sort of integrate this space, time, and theme dimensions in, again, sort of one framework. The location categories, again, we can use this to explore different structures in space. And same with the temporal categories, we can use this to examine different temporal structures, repeat structures, and temporal trends. And Judy made the good point the other day that not every visualization does everything, and they can do different things and do different things differently. And so this is, there's missing pieces here, but because if you might still need a map in order to get the spatial specificity of where these events are occurring. But I think the advantage here is that, again, you have sort of a unified framework that simplifies some detail and increases the potential from pattern discovery by decreasing that, taking away some of that detail, and let the pattern sort of shine through. So thank you very much.